Good afternoon, everybody. Welcome to the last week of the talks of Geoheritage Month, September. Today, it's a great pleasure to introduce Bastien Linol, who joined us from France in 2008. He graduated at Nelson Mandela University in 2013. And he's now a research fellow at AEON. He's recently published an interesting paper on Earth Stewardship Science. And one of the initiatives that talking about following up in that issue is the Africa Alive corridors that Maarten initiated way back at the turn of in this new decade. Bastien today will be talking about the pillow talk paper that he completed with Maarten, and we'll just have a few words to say about Maarten, what a great teacher and leader he was. With that, over to you, Bastien.
Right, thank you. I'll share my screen and put the PowerPoint. I think it's gonna go for 30 minutes. And maybe we discussed afterwards, I imagine. Can everyone see my screen? Because I cannot see you.
It looks good, Sebastian. It looks good.
We can see it.
Okay, so this is the first slide Maarten has been using for the past few years. Let me see if I can get the text going. And the title of the talk is Maarten de Wit's Legacy, the Rise of Southern Africa after Karoo magmatism. So basically I split it into two, where I'm gonna show some few slides about what I think Maarten have left behind, but I've been under him only for the past 12 or 13 years. So this is just gonna be about the recent work. And the very recent paper we published in the South African Journal of Geology, which is about Drakensberg volcanics and its links to better understand the Kalahari epeirogeny. So yeah, you've introduced Maarten. When he passed away, he was a professor of Earth Stewardship Science at the Nelson Mandela University. And yeah, over the past 12 to 13 years, he's been a grand mentor for my research on Africa geology. His view before he passed away is that we should look at the Earth as a commons, a place where we live and where there are complex problems, and we need to try to solve them as a group. Okay, so this is our John, his group. That group was mostly him in UCT. He had a separate building, and this is a common room. With lots of maps and students passing around. Here is Scott McLennan. He was, Maarten convinced him to do some research, and he did a PhD, and Maarten helped him to go do this in a very prestigious university in America. So with him and others, we were working on some maps, and most of the work was to transform the paper maps into a geodatabase. So next to this room, there was a big room with 10 or 15 computers and ArcGIS. And I think when I joined this commons in 2008, it was mostly the outcome of a big computer center where we make maps and model. And one of the big outcome was Gondwana map that Maarten designed it in the 80s, that now is fully digital, for example. So he was working a lot on the geology of different places of the world, especially the geology of the supercontinent. And another example that you can find online is this new map of the Congo outlier. That's the results of 30 or more years of field school near the Cango Cave. And on the very a few months ago, we managed to finish this paper, which is called Proterozoic, Paleozoic Sedimentary Rock and Mesozoic, Cenozoic Landscape of the Cape Mountain across the Congo complex reveal more gaps than record from Rodinia and Gondwana to Africa. So it's a very long paper. It integrates lots of concepts of geomorphology, geology, and especially it's very well illustrated with maps and photos. The background is the map from him, but we had to digitize a small part of it. So he was very famous at the university because many students, I think, will remember his class, which was very much about the Africa plates, the geopolitics, and different aspects. So he had a great knowledge on Africa, and this was part of two big programs, one with the German, the INCABA program near Africa, and the program with the French called ICURE. So I came in 2008 in this setup because I speak French. I spent some time in the Congo, in DRC, and I helped him to publish this important book, The Geology of the Congo Basin, in 2015. And these two programs consolidate in a bigger, more transdisciplinary program called IPACADE, which is a Xhosa word that means observe the present and consider the past to ponder the future. And he created the Earth Stewardship Science. This was very much consolidated at the Nelson Mandela University. So here is one of his slides when he introduced his concept to the university. He expressed that things are changing, and now we cannot just do basic geology as we used to do in the old days. We need to understand the system because they are complex from different aspects. So you can read. The last paragraph is, we cannot understand any of these problems, let alone solve them in isolation. Uptake will depend on a mix of unbalanced growth among science, economic, regulation, policy, behavior, and so forth, at variety of scale and with plenty of bottlenecks and tipping points along the way. But ultimately, it will rely on appropriate data and how this can be best interpreted by and for a new generation of Earth stewardship researchers. So this really expanded when it came to the Nelson Mandela University, and part of this transdisciplinary research was founded by the Eastern Cape. This was the Karoo, which I think is the slide afterwards. So this is how the Earth Stewardship Research Institute is located, is in the center, in between different faculties at the university. So it's a strange position. And it do research on socio-ecosystem services and socio-economic services. And this is linked to many contacts, most of which Maarten had with some big groups, like the ICDP. Of course, he had a lot of funding from the NRF. And all of this turned around four big themes: the course on Africa, which I talked about, ocean science, the super deep drilling lab, which I will talk about, and the Africa Life Corridor, which I think John Anderson will talk about in one of your presentations. So at the Nelson Mandela University, he started the Karoo baseline. So this, at this stage, was done by 35 postgraduate students. I was one of them doing my postdoc in the section Earth, and there was over section groups working, a big group working on water and group working on social issues. and as well as one master student doing a documentary of what the people are doing. So on the right, you have pictures that illustrate some roundtable meeting in Cradock, the new geophysical equipment that they acquire, and some of the water testing. This baseline study at the bottom in green, geoscience, soil science, seismicity, agriculture, we're here to feed into a very large science and technology laboratory, which would be mostly around drilling. So Maarten had this vision of transforming the Karoo into a sort of Silicon Valley. So he called this the Cango Heights. And this was at the background is the city of Cradock. So this is how he envisioned the future of South Africa, was to help with development by having this Silicon Valley in Cradock. So we made a view here, a Google Earth view, where we installed the 3 deep drilling center, a university, and all the things that go around, like conservations, farming, of course, a lot to do with drilling. And his argument was that nowadays drilling is very much about computer systems, and that there is no reason that the young in South Africa cannot play video game to see what is under the ground. So he compared this to the SKA, which is in South Africa, but looking down into the earth, into the geology, with three sort of theme. One to drill super deep to see the origin of life, another one to do some tests for fracking, and another one to look at geothermal energy. I've also helped him to do a proposal on the Indian Ocean, which was quite big, and this was to link the climate and the biology to plate tectonics. So we designed a very simple model. Here's animation come in. So where the DNA of the species in the Indian Ocean would be the results of mix between DNAs coming from warm current through the Indonesian gateway, which is currently closing with this plate tectonics, and mixing with some of the current and river against Africa, and interacting with some fresh water coming from the Southern Atlantic. So this was a very big proposal, and very interesting is an animation that demonstrates how recent and how changing is the Indian Ocean, with India crossing all across the ocean to now form the Himalayas. And it is well known that the Himalayas, this Himalaya origin, have a significant impact on global climate. So we were asking the question, what can we learn about the geoecodynamics of the Indian Ocean more than just the Himalaya origin? And it is clear that Africa have also impacted this evolution. I want to go to the next. So he identified numbers of partners to work with the Nelson Mandela University. These are the red spot. He had a great knowledge of many of, and visited probably many of his centers. And this was to work with the Nelson Mandela University, which now this university has opened an ocean campus. And Maarten was a pioneer in getting this going. So here's a 3D false color image of Port Elizabeth, just to show you that it is a great place to study this Indian Ocean complex system. We have different surfaces here. You can see flat surfaces, very well preserved. And we did document some of this in one of the first, I think, Mandela talk, which is online on our website. Here's one of the rapid reconstruction I did for this video, where you can see sea level rising across the Algoa Bay and Port Elizabeth up to 200 or 300 meters above sea level. This is some of the fossil sites. So here's an oyster bed preserved at Grass Ridge, where we often take the students and visitors just to show them the problem of epeirogeny and sea level change. Here's Maarten at the back. You can see with his hand is teaching this young group from MIT what is relative sea level. So I have a paper in preparation on this. And most of the analysis here on the right, you have a SIMS were done overseas, since we don't really have the capacity in South Africa to do this kind of detail work. This is a summary slides that show the different fossil sites that I've studied with the stars. And after demonstrating that most of Southern Africa was uplifted during the Cretaceous in the early work that Maarten did at UCT. Now what we have to do is to connect this epeirogeny with sea level change. And at the bottom, you have a curve of the changing temperature through time. We need to link this to a curve of the uplift of Southern Africa. And that's not an easy thing to do, because it's very difficult to decipher which of these two vertical movements was predominant at different time of the evolution of Southern Africa. And that's particularly important because it is predicted that in 30 years, the temperature will increase by 1 or 2 degrees, and that sea level supposedly global sea level will rise. So that's the research company we made. We found many pilolavas. So these pilolavas, it's magma that comes out from the center of the Earth, but comes down very fast in water. You can see this process form bowls. So we found these pilolavas in the Drakensberg very high in the landscape. And they are the proof that this magma, this magma, were erupted underwater. Now there is a bit of controversy if, of course, they were erupted in the sea or in the very small lakes. But in our publication, we argue that they must have been erupted under the sea. So the first argument for that is that you found them everywhere. Here's a map of the area around Lesotho. All the green squares are known pilolava today. In the small box, there's the paper. So there is only a handful of paper that describes them, and most of them are very old. So you can see some are found in Zimbabwe, in eastern Botswana, and a few here across the Drakensberg. All the references are from the 70s. Here we can use the work of Scott Lee in Lesotho from the 50s. And there's only one really recent paper that mentioned these pilolavas. So around it, you have the site that I've investigated and the elevation. You found them at different elevation between 1600 meters up to almost 2200 meters above sea level. And you found them mostly to the south of the Cape Bar Craton. So here in dotted line, you have the boundary between the Archean and the Mesoproterozoic. So we will argue later that most of the Mesoproterozoic flanking the Cape Bar Craton was below sea level, because we found these pilolavas in many places. And there are probably more, since in many places, the basalt completely cover and we don't have any outcrop of the lower sequence. So this work started, I started this work when I joined at the Nelson Mandela University. At the bottom here, you can see a picture of one of my first field trips where I was going to celebrate the Christmas in the Drakensberg. At that time, I had a city Honda Civic, so I had made problem with my radiator, but I visited a few places over the past 7 years. So this was a black box. You can see I was very interested into the contact between the sandstone and the lava. On this Google Earth map, the perimeter of this volcanics in purple is more than 8,000 kilometers. So you can imagine how much work is still need to be done to cover all these places where there may be some potential over pillow lavas. I've also put, for those who don't know the geography, the highest point, Tablana and Tleniana, which I visited with my sister when she was in holiday, at 3,482 meters above sea level. So this will require a lot more work to characterize the beginning of the volcanism in the Karoo. That's the work I've done with Maarten, so I was very lucky to share some field work with him. Over the past few years, we went to the Drakensberg and across the Karoo 3 or 4 times camping, and sometime with 2 4x4s, each one with our horn, and we would follow each other. And the deal was that the one who's driving first, when he found something interesting, he'll stop, and so that the other one has to stop. So here at the bottom, we passed next to Lock's Bridge, and I wanted to take a picture of this meandering river. But while I was doing my panoramic pictures, on the side of the road is Maarten finding the pillow lavas. So he was very excited. This was in 2016, and he made a big deal out of this. But it came really as a surprise. There is a picture of camping in Lesotho, but what was really fun was to travel across and camp together and see that, like him, I was enjoying being in the field, braying, and simple but sometimes a bit rough way of doing field work. So this was great. This is an example of the section we did at Lock Bridge, where there was this meandering river and where we found the pillows. So above is a cross section. On the side, you have a stratigraphic column. It's not very detailed. The small rolls are the pillow lavas. You can see it's complex. You have some pyroclastics that are preserved, the green here, some breccias. These sit on top of a sandstone basement, but lower down in the stratigraphy, we'll find the Clarence sandstone, and it is made of different units. In the old days, there are different names: the Johnville member, the Donnybrook member, the Cry River formation. The pillow lava in this section are found here, and there is no date for this whole section. So in the more regional framework here at the bottom right, this section sits near the top of the Clarence formation and under the thick basalt of the Lesotho formation. And there is no age between the Elliott formation, which is even well below and over 300 meters below. So our section is constrained in age between the Triassic-Jurassic boundary at 201 million years and some of the lava and dolomite that are well dated at 182 million years. So that gives us a time span of more than 20 million years where this unconformity must have had some significant time missing and erosion. So this is another argument for having the sea in the Drakensberg, because there is a lot of, in this section, for example, there is evidence, there is significant hiatuses and unconformity at the top of the Clarence sandstone. And within the, it's called the Barclay East Formation, the lower Drakensberg group. So you can hear me. Maarten on one of his trips bought me a drone. That's a small one here on top. It's about like 15 centimeters. You can put it in your pocket and do field work with it. Basically, it's like a very good cell phone that is flying. It has 12 megapixel camera. And on this particular site, the next pictures, I took more than 1,000 pictures. You stitch them together and then you get a map or a 3D model that is very, very accurate because you have so many pixels. Now, if you couple that with a very high precision GPSs, then you get very high resolution maps. And for teaching and for communicating science, movies are great. So here you can see at the bottom one of the students is acting as a scale. You can see the pillows. It's now this round picture here. And I bring the drone close, so you get very sharp pictures that you can use for your geological mapping and for the cross-section. Here you can see the pillows are covered by some sediments. There is a conformable contact, and here are some closer zoom. So yeah, it's not easy to work with the drone. I lost one drone doing this survey because the cliff, you can see the cliff is huge and it's very steep. So it has been a challenge. And so now I'm working with the second one, second drone. They cost about 15,000 rand. So these are like, these are really, you get them off the shelf. And when you have an outcrop like this that is so steep, it is very useful to have a camera that you can bring behind you to have a better idea of the geometries. I've got more example. I can stop this. Here's another drone pictures from one of the top next to the Lesotho border. So with the drone going up to 100-meter heights, you have some while you are mapping, you can get pictures. So like this one here, you can see the white outcrop of sandstone. And then on the top here, you can distinguish maybe some different rocks, which are basalts. So this shows you the contact between the sort of Clarence formation and the lavas. So there is about like 400 meters of section to make this contact. And there are some marker beds like this one. But a zoom of one of them. We are here at the bottom, flying the drone to make this nice cross section that we will not be able to do if we were just like walking around this steep cliff. So you can see the tuffs here in green, and there is some sandstone beds that are below the sharp contact with the basalts. And within the sandstone, there is an intrusion of lava that comes from the left. I think it's the south, but it's not orientated. Sorry about that. Sorry, here's one last example of a drone picture in Lesotho. On the geological map, you have some red beds here. I think it's attributed to the Elliott Formation. And then above that, you have a section of different units of lava flow, breccia, tuffs. Here we discovered some new pillow lava, and then you can see at the top here are the more massive basalt. So it is about like 600 meters of section, and we've started by doing it here along the road. And this picture of the drone that will help us to identify the next place where to get outcrop. This was just to demonstrate you are useful with the drone. So on the pillows, Martin's colleague has done work on the vesicles, the bubbles that are fossilized in the pillow lavas, which are in white on this picture. So here's an example. I've done the work. It measures the percentage and the diameter of these vesicles, and it calculates depths of eruption for the pillow lava of about 500 meters deep. That's this number in red on these two graphs. In his lab, he also has done all the geochemistry of the major and minor element. I will pass on that. This is the classification. Our samples are in red, in both compared to other studies. So there are work in Botswana and a lot of work in Southern Africa. So most of the red points, our samples are very similar to the rest. And we've done some isotope chemistry. Again, our samples are in red. So on the left, you have the oxygen isotope plotted against an index for alteration. So sort of generally, the oxygen isotope increase with the alteration index. So this is a characteristic of alteration at low temperature, from my understanding. And the strontium isotopes are very close to the strontium isotope of seawater, which is this green spot, or it's almost identical. So this is another argument that this pillow lava could have erupted 500 meters under the sea level. So if this interpretation is correct, this has significant implication for different aspects of Gondwana. The first one is we have to correct many maps, like this one from Buckley, which is a very famous data set of maps. I had to paint in blue most of South Africa, if our interpretation that the pillow erupted under the sea. And this would also have a significant implication for people working on the fossil record, as they are describing an anoxic event. So if the first eruption were happening under the sea, this would have more significance for this anoxic event that they are talking about. In terms of the reconstruction, we didn't do a great reconstruction. We used a loose fit because it's very difficult to fit the different elements. Things like this block, the earthwork with more terrain has to fit in somewhere, and that prevents really to put Antarctica right against Southern Africa. And there are now geophysical data, these two sections, A and B, which are here, A and B, that show that the crust offshore is still significantly thick and continental. So it is about 40 kilometers thick, and it is the same. So we still, even with the new reconstruction model that exists, we are still very much in the loose with that fit, how to bring the block together. But the point we wanted to make is that this crust is relatively whole and has been dated in few places, especially in South Africa, and it's part of the Namakwa Natal terrain that's bordering here and likely extend in many places, but are now spread out in the Indian or Southern Ocean. So we would need more of this geophysical study to identify where the different block of continental crust has been spread around and thin it. Okay, one of the examples we have for this triple junction is Afar, and this recent book published by Varet is one of his picture from the book, which detail the sort of geometry of the Afar triple junction that we think is a good comparison for the Karoo triple junction. So in red, you have the transform fault, here is the Red Sea, and these are connected by transform fault, and they're connected to the main East African rift here. I think everyone will know the cross section is a cross section across the Red Sea. So these are the rift, there is volcanoes, and at depths you found some intrusive rocks at depths between 5 and 10 kilometers below surface. So this is another field photograph taken from the book, where you can see the cracks and then the volcanoes, the sort of models they have, how the eruption may have taken place. So this is very similar to what we found in the Drakensberg and Karoo area, where the dolomites are cut crossing the Drakensberg group in purple here. And so this is around 2,000 meters above sea level. And then we found them all the way down to the coast, and we found them in deep bores. So this is about the same depths as this model for the Afar. And many of these dolerites are not precisely dated. Only a few have precise date that constrain the minimum age for the Drakensberg group in purple. So here's a date by Burgess et al. It's 183 almost 3 million years. And these are some dates by Thomas Mwedi, which I think is trying to publish. Is dated 4 or 5 new dolerites. The numbers are in big here. So he has a date of 183.1, 183.0, and it might be that the age of crystallization of these dolerites is becoming a little bit younger as we go towards the coast. So this is why we have this arrow here in red, that maybe crystallization was progressing in that direction, but there is not enough dates to improve this model. So in conclusion, the AFAR is a good comparison to the Karoo triple junction that we name Limpopia here, but with some significant differences. The first is the size. It is clear that the Karoo triple junction was much larger than what is the AFAR. As you can see, they're at the same scale. And also that the uplift in the AFAR has been dated to be younger than the opening of the Red Sea of about 40 or 30 million years. While in the Karoo, if the pillow lava erupted below the sea, and the epeirogeny is mostly much younger and Cretaceous in age, there is a significant difference in the timing of mantle upwelling. And we interpret this to maybe to be related maybe to the difference in subduction zone associated with this mantle upwelling. In the AFAR, there is only a subduction to the north, I cannot see under these things, and abduction of in Oman, while in the Karoo, it is known that it was north of a very large and prolonged subduction zone at the edge of southern Gondwana here. So we relate this difference to these processes. Okay, so that was a summary of the paper that is now published in the South African Journal of Geology. We want to thank, we had some very good and detailed review about the work. So it was great to work with our reviewer. On the other side, some of the reviewers disagreed a little bit with some of Martin's ideas. They didn't, not all of them understood why we called this paper Pillow Talk, but I hope now you got a better idea. Luckily, we were able to acknowledge who we wanted. So he really wanted to acknowledge Doris Day, because my understanding was that he really liked his TV show while he was younger. And he already had a paper called Pillow Talk 1. So now we have a Pillow Talk 2. And the title is Early Volcanic Rocks of the Karoo Lip Formed Mini Leagues Under the Sea. So we proposed to have this picture on the right as a cover. I mean, that's what Martin wanted. And you can see this is what the journal has done. So we didn't completely honor his wishes. But this is because Martin have a very different vision, and sometimes people not completely understood why this was important, why he would fight so much to get what he wants. So I got his final notes from his family. We finished, the paper was finished the day he passed away, the night before, but on one of his paper, he had unwritten short text, which I have put at the end of the paper. And it says, one of my main goals with this paper is to encourage new young South African geologists that the Karoo Plateau is a great place for mapping, most of which still depend on the map of Du Toit. It is time to move on for South Africa and by South African geologists. So yeah, I think his message was clear. He was encouraging everyone to go in the field, and I believe to work on the Karoo and the Drakensberg, it's a long time task, but that would be fun to do. So yeah, I'm continuing this work, and yeah, thank you for listening. This is the end of my presentation. If you want to discuss, I'll stay around.
Thanks so much.
Thank you, Bastien. You want to take it, Nolene?
No, all yours.
Okay. I don't know where Chris is, but if there are questions or comments, now is the time to raise your hand or unmute your mic.
Can I say something? Can I ask Bastien something, Craig?
Yes, go ahead.
Bruce Rubich here. Bastian, I really enjoyed reading that paper, and it gave me new insight. I hadn't thought about all of these things, and I certainly hadn't thought about the pillow lavas being under 500 meters of seawater. So that was very interesting to me. But what I need to try and understand in my own head is when you look at the development of the Karoo Basin, it becomes progressively more arid. We've got lots of terrestrial fossils, dinosaurs and things that occur in the Elliott Formation. And then in the lavas, between the lavas itself, in those sedimentary packets between the lavas, there are footprints of dinosaurs and fossils. How does that get explained by 500 meters under the sea?
You are cutting a bit, Bruce, but yeah, I think I heard your question. Why do we have fossils below and well above our layers of pillows? And the answer,
that's
is
basically my question.
The answer is simple, is that in stratigraphy, there is a lot of time that are missing. And there are many unconformity between some of the Elliott fossils you have, and then some of the footprint you have on the top, which are, I think, part of the Lesotho formation. So in fact, there is, in the South African geology, there is two formations. There is the Clarence formation that maybe have still some footprint. And then there is the Barclay East formation, which from my literature review, there is very little fossils and probably a lot of time missing in between the different layers.
Okay, I understand that there can be time missing, but how does this get under the sea? That's what I'm trying to understand. I'm trying to understand that from your model. Because there wasn't sea nearby at that stage, as far as my understanding is. There was the early Karoo Sea, which gradually sedimented. That was the contact between the Eka and the Beaufort groups. And then it became a terrestrial environment. I'm trying to understand where the marine component then came in Drakensberg times.
We compare this to the Red Sea. Like we may have a Red Sea that was coming close by. And in the case of the Red Sea, the seawater come by. There is so many fractures that even if there are legs, they become saline because they are connected through the fracture to the ocean. And in that particular time, we call this Limpopo, but the sea was not very far in the south of Gondwana, near that subduction zone. And all these microplates that we have difficulties to put back together. Does this answer?
Gives me good food for thought. It provides an answer to think about. Yes, thank you, Bastien.
Of course, Bruce, it would be nice. It would be a very much stronger argument if we would have had some fish fossils or any fossils at the bottom of the lava. But the geology is complex. There's lots of volcanoes. There's lots of erosion and slope deposit. That's it's very difficult to reconstruct the environment between the Aeolian deposit and then the lava.
Are there any other questions or comments?
Just to go back to the introduction, Bastien, you spoke about NMU having an ocean. Maarten initiate this idea of an ocean campus. What's happened? What is that campus about?
It's an extension of the university. I'm not sure in terms of admin where it really works, but they've built a center especially to do science related to the sea. So in the old days, it was mostly with the biologists, people looking at dolphin or at the flora under the sea. And they do not have a geology and geophysical component into that. But because AEON is a separate group, we don't contact, we're not collaborating enough with them. But yeah, they have a facility, the Ocean Campus, but they don't yet have the people. So it's something that will grow over the future years.
Okay, thank you.
Is there anything more that anybody would like to ask or comment on? Going once, going twice. With that, I'd like to thank Bastien very much for giving this talk. And it's a suitable memorial to Maarten, who we all know and we've all had interactions with at one time or another. He was a great scientist and a great thinker, and we'll all remember him for that. I would also like to thank Tacoma Strategies for being the sponsor for this month's meetings. And we come back again tomorrow for another one. So thank you very much for attending. And with that, I'll close the meeting.
Thank you, everyone.
Thanks, Bastien. Ciao.
Thank you.
Thank you,
Bye.
Bastien. Bye.